You might be thinking, what do square roots in geometry have to do with one another? Well, Pythagorean theorem is kind of important in geometry, and it kind of requires square roots. Therefore, these went in the same chapter, apparently. So, a perfect square is the square of an integer, so the integer multiplied by itself. Now, a square root of a number is one of two equal factors of the number. It's very important to note that in different places, this has a different convention. Like in North America, this is the positive square root of x. However, in most places, you don't bother putting the plus minus because it is understood that there are two square roots just from the square root symbol. In North America, you actually have to put the plus minus if you want to make it clear that the negative square root also counts. Like say, negative 2 times negative 2 is equal to 4. 2 times 2 is equal to 4. But when we press the square root button on, say, our calculator, it always gives us only the positive. In North America, you consider this to mean the positive square root. Now, every positive number has a positive and a negative square root, but for our purposes, we have notation that varies depending on region. So the square root of a negative number is not real because the square of a real number cannot be negative. However, square root of negative 1 is the imaginary number I, which we will learn much, much later. For now, we just need to know that it's not real. Let's find some square roots. 144 is 12 times 12, so square root of 144 is going to be 12. Negative square root of 121 is negative 11. And plus minus square root 4 is equal to plus minus 2. Or depending on where you are, it might be 2 or negative 2. Make sure you know your local convention. Now, plus minus 2, but you can get away with that basically anywhere, but preferences may vary somewhat. Just be careful. So example 2, let's use a calculator to find the square root of 34 to the nearest tenth. So we put 34 and we use square root key, which should be present on your calculator, even if it's not a scientific calculator. And you end up with 5.83095, etc. But we want to the nearest tenth. So square root 34 is approximately equal to. Note that symbols may vary for approximations. This is approximation in North America. In East Asia, as far as I know, it's this, like double squiggle. So it's 5.8 to the nearest tenth. Now, let's find some more square roots. Negative square root of 100. Well, 100 is 10 times 10, so that's equal to a negative 10. Square root of 256. 256 is 16 times 16. Square root 4 is 2. Square root of negative 4. Technically, it is 2i if you studied imaginary numbers. But for our purposes, not real is what we write. Negative square root of 144. Negative 12. Negative square root of 225. Well, 225 is 15 by 15, so that's negative 15. 289, that's 17 by 17, I do believe. Yes. And so that's plus minus 17. Never feel bad about using your calculator if you need to. Mental math is nice and all, and sometimes can avoid mistakes that might come from too much button mashing, But if you need a calculator, you need a calculator. Just make sure you get your question right, okay? Well, your answer right. Yeah, okay, getting the question right is kind of important to getting the answer right. You'll find that to be particularly important in geometry problems, which we'll be doing later. So 484, that's 4 times 121, which is 11 squared, so this is going to be 22 squared. So that's going to be 22. Square root of negative 25, not real, is what we respond for now. 361, you know what, let's just use this calculator. And that's going to give us plus minus 19 here. And 1521 square rooted gives us 39. And now we will once again take up the calculator so that we can find square roots to the nearest tenth. Okay, so 11 square root, and it's approximately 3.3. 19 square root is approximately 4.4. Negative square root 47, well, that's approximately negative 6.9. Negative square root 57, that's approximately negative 7.5. A 172 square root, that's approximately, well, it's to the nearest tenth, so 13.1. 521 square root, oh, that's approximately 22.8. And 427 square rooted is approximately 20.7. 310 square rooted is approximately, well, negative square root 310, that's very important. Negative 17.6. 490, that gives us approximately negative, that's important, 22.1. So yeah, basically make sure you know where your square root key is on your calculator, whether it's scientific or otherwise. Now, earlier we had some numbers, like say negative square root 25, which we said were not real. What's that about? Well, real numbers are defined like this. They're very specifically defined. They include all natural numbers, which are numbers that occur in nature. In other words, positive whole numbers or positive integers. 0 may or may not be a natural number, actually. Integers, i.e. all whole numbers, negative and positive and 0. Rational numbers and irrational numbers. Now, depending on where you are, you may see whole numbers defined as a subset of integers, including 0 and positive integers. Like, say, perhaps in some places in the US. However, for most of the world, natural numbers includes all positive integers and may include 0. Why? I mean, naturally, a person can be holding 1 apple, 2 apples, 3 apples, 4 apples. But I'm quite sure the editor of the usual math textbook will very astutely observe that while they're busy editing and deciding which definition of natural number to use, there were precisely 0 pink elephants stomping on their face. Whoa, right? So, that's why 0 is considered a natural number in many places, whereas others apparently didn't quite think this through. Just make sure when you're dealing with a problem that you actually know which definition of natural numbers they typically mean in your region or wherever the contest comes from that you're doing, okay? So, what's a rational number? Well, a rational number is any number that you can write as a fraction. Like, say, 371 over 100,001. This can be written as a fraction, and therefore it is a rational number. An irrational number cannot be written as a fraction, and it's a decimal that doesn't repeat or end. So an endless decimal, like say pi or e, this is the natural coefficient. Pi has infinite places. It does not repeat itself. All fractions, once you divide them out long enough, will eventually repeat themselves. Okay, so name all the sets of numbers to which each of these real numbers belong. Now, a number that is not real can be imaginary, such as square root of -1, which is the imaginary number I. But for our purposes, we generally keep our math work to the real numbers, at least for this grade level. 7 is a natural number. It's an integer. And it's a rational number. Rational number. Okay, 0.6 repeating, that is rational because, well, it's a decimal that repeats itself. In other words, it can be written as a fraction. Rational. Square root of 71 is irrational. It cannot be represented as a fraction. This is a common property of square roots that are not just integers or fractions, because you can totally take the square root of 81 over 25 and you would get 9 over 5. So this would be irrational. -81 over 3, that's equal to -27, which is an integer. And a rational number. I'll just write rational. Negative root of 169, that's -13. So it's an integer, and it's rational. Now, in the United States, you have some specialness, American exceptionalism. Yeah, in the US, whole numbers refers to 0, 1, 2, and so on. So, in other words, 0 and all the natural numbers as the Americans reckon it. Yeah, most of the rest of the world say that, yeah, either have n including 0 or you have n plus, which explicitly excludes 0. And integers, for most of the rest of the world, integers and whole numbers mean the same thing, but this is USA version. W is this. It's important to note that the Americans do it this way. Now, 21. Is this a natural number? Yeah, it's a positive integer. Natural number. Is it a whole number? Is it an integer from 0 to positive infinity? Yeah, according to the Americans. The rest of the world doesn't really bother that much. Is it an integer? Yeah. And is it a rational number? Yes. It's not irrational. 3 over 7 is not an integer, so just natural numbers, whole numbers, irrelevant. Because all natural numbers are whole numbers, and all whole numbers are integers, but not all integers are these, in Americans' terms. So it's not an integer. Is it rational? Is it representable as a fraction? Yeah, it kind of is represented as a fraction right here. Same for 8 over 12. And negative 5 is an integer, and it is rational. 17 is a natural number, a whole number, integer, and rational. 0 is a whole number. It's not considered a natural number in the United States. It's an integer, and it is rational. 0.257 is rational because it can be represented by a finite decimal or a repeating decimal, although that's not relevant in this case. It's not an integer, though. 0.9, yeah, same thing. It's a finite decimal, therefore it's rational. 78 is natural. It's whole, it's an integer, and it's rational. 1 over 4, that's rational. It can be represented as a fraction. However, it's obviously not an integer. Pi is irrational. It's a infinitely long, non-repeating decimal. And negative root 169 is equal to negative 13, which is an integer and rational. However, if it was, say, negative root 168, it would be irrational because square roots that don't evaluate to integers are infinitely long and non-repeating. 5.7 is rational. Negative 8.5 is rational, but obviously not an integer. Negative root 289, that's 17, I do believe. Yes, yep. 17 squared is 289. So negative 17. And this is an integer and rational. If we're going to talk about Pythagorean theorem, we kind of need to talk about triangles. What is a triangle? It's a closed geometric shape made out of 3 straight sides with 3 angles between each pair of those sides. And, well, 1 angle between each pair, a total of 3. Okay, better. Yeah, so you have the angles adding up to be 180 degrees. Find the value of x in triangle DEF. Well, then, we know that x is equal to 180 degrees minus angle FED, D minus angle FDE, which gives you 180 degrees minus FED is 52 degrees and FDE is 43 degrees. So 180 minus 52 minus 43 is 85 degrees. Now, if we classify angles, You probably remember this from previous grades. An angle between 0 degrees and 90 degrees is called acute. An obtuse angle is between 90 and 180 degrees. A right angle is 90 degrees. A straight angle measures 180 degrees. And a reflex angle is beyond that, all the way to 360. Okay, if we classify triangles by their angles, since the total is 180 degrees for the interior angles, the largest you can get for an interior angle is an obtuse angle. So if you have one obtuse angle, you don't have enough degrees left for anything but two acute angles. So obtuse triangles have one obtuse angle. Right triangles have one right angle. But acute triangles have all acute angles. Now, if you classify triangles by their sides, isosceles triangles have at least two sides equally long. Congruence for, say, length just means that they're equal, they're the same. But for shapes, congruence means that the shapes are the same in all ways. Now, can you say this about two equally long lines? Well, congruent shapes, you can flip them, you can rotate them, but they'll still be the same. So, with straight lines, yeah, as long as they're the same length, they are congruent. Equilateral triangles have all sides congruent, or just all sides equal. All angles are also equal at 60 degrees in equilateral triangles. Isosceles triangles have two sides congruent, and then those angles would also be equal. Scalene triangles have no congruent sides. This triangle here is, well, it does not fulfill the angle requirements to be isosceles or equilateral. There are no equal angles, and all the angles are less than 90 degrees. Therefore, this is acute and scalene. Let's do some exercises. Find the value of x in each triangle. Then classify each triangle as acute, right, or obtuse. Well, here, x is equal to 180 degrees minus 112 degrees minus 17 degrees. That means we're looking at 68 degrees minus 17 degrees, which is 61 degrees minus 10, or 51 degrees. Okay, this is obtuse because there's an angle that's greater than 90 degrees in it, the 112. What about number 2? Well, x is equal to 180 degrees minus 62 degrees minus 57 degrees. Now, if this had been 58, this x would be 60, but it's not. So we're looking at 61 degrees. This is acute, this triangle, because all three angles are acute. Now here we see that this is obviously a right triangle because there's a right angle marked right here. But how big is x? Minus 90 degrees, minus 22 degrees. Equals 68 degrees. Because it's 90 minus 22, which is 70 minus 2. This is right triangle. Classify each of these triangles here by the angles and by the sides. Well, this one is a right triangle, and we can obviously see that it is scalene. Oh. Right scalene. This one, we have 110 degrees up here, and these sides are equal, so this is obtuse, isosceles. And the 60, 60, 60, that's going to be acute, because 60 degrees is less than 90. And it's equilateral. When all the angles are equal, all the sides must also be equal for a triangle. This does not hold true for, say, a four-sided shape, as anybody who has seen squares versus rectangles can tell you. Now, the Pythagorean theorem, which goes by many different names depending on which cultures you come from, this states that if a triangle is a right triangle, then the square of the length of the hypotenuse is equal to the sum of the squares of the length of the legs. In other words, if you have this right triangle, you take the squares of the shorter sides, which are next to the right angle, you add them together and you get the square of the long side. A squared plus b squared equals c squared. For example, here, find the length of the hypotenuse of the right triangle. C squared is equal to 16 squared plus 30 squared. Oh, by the way, this is why you sometimes can see the Pythagorean theorem written as c squared equals a squared plus b squared. It's just that when people read things, they like to go in alphabetical order for various reasons, and that's why it's a squared plus b squared equals c squared. But you end up rearranging and isolating your unknowns on the left side usually, which means you end up with this. C is therefore equal to square root of 256 plus 900. So the square root of 1156 is 34. And do we have to put units on this? Well, these are in centimeters, but hey, C centimeters. That means C is just a number. If it said 16 centimeters, 30 centimeters, and then just C, then we would actually have to put centimeters here. So the length of the hypotenuse is 34 centimeters is our statement if we were to write it. Which you should for all word problems, by the way. Like for school, generally it's accepted standard that you write out a statement for every word problem. For our purposes, we're going to save ourselves a little time and save you a little bit of boredom staring at me just scribbling on a board. Yeah. So let's find the length of the hypotenuse in each of these right triangles and round to the nearest tenth if necessary. Okay then. 1, you have c squared equals 15 squared plus 20 squared. So that's 225 plus 400. For hopefully obvious reasons, we don't account for the fact that the square root can be negative, even in countries where the square root by default means plus minus square root. In North America, it just means positive, which is probably because having this side be negative 25 inches long is a little bit nonsensical. Okay, so square root of 625, which is, well, 25. Do we put units here? No, because it says c inches. What about here? Well, we have c squared equals 11 squared plus 12 squared. Therefore, c is equal to square root of 121 plus 144. So, plus 144, 265 And when we square root that, oh dear, we're going to have to round to the nearest. Check back at the problem whenever you need to. Okay? Better to check back half a dozen times and then get it right than to not check back out of misplaced pride and get it wrong. 16.3. And yeah, this is in meters, but meters is already stated here, so we leave it at that. So 25 squared plus 35 squared, which, oh wait, no, 25 I can just do right off like that. And 35 squared plus 1225. That's C. And the square root of 1850, which is approximately 43.0. We keep the 0 here because it said round to the nearest tenth. And keeping that 0 there assures that, yeah, it's to the nearest tenth, guys. It's not just 43. And then we don't know whether it's 0.1 or 0.4 or 42.5. Yeah. So, if C is the measure of the hypotenuse, find each missing measure. Round to the nearest tenth if necessary. Well, C squared equals a... Technically speaking, we should go with A squared plus B squared, but you can see where this is going. 18 squared plus 80 squared. So, 18 squared is 324. Plus 80 squared, 8 squared is 64, so 6,400. And you're looking at square root of 6724, which is 6724 square root 82. Hurrah. Okay, C equals 82. Now for this one, you have A squared plus B squared equals C squared. A squared plus B squared equals C squared. So therefore, A squared plus 70 squared equals 74 squared. A squared is equal to, let's calculator time, 576. Therefore, A is equal to 24. Alright, so how about A equals 14, B equals, we don't know, C equals 22? Well, A squared plus B squared equals C squared. B squared, we don't know, equals 22 squared minus 14 squared. 22 squared minus 14 squared equals 288. Well, B is equal to square root of 288. And that's going to be approximately, it was round to the nearest tenth, right? Yeah, to the nearest tenth. That means we end up with approximately 17.0. So, this last one, we have A squared plus B squared equals C squared. That means A squared plus 48 squared equals 57 squared. A squared is equal to 57 squared minus 48 squared. So 945. Therefore, A is approximately 30.7. Right. Okay, let's say we have three sides of a triangle. Determine whether each triangle is a right triangle. How can we do this? We can compare the shorter sides squares added together versus the longest side squared. So short side square sum versus long side square. Yeah. So c squared is, the longest side of here is 34 squared. That's 1156. A squared plus b squared is 16 squared plus 30 squared equals 256 plus 900 equals 1156. So, because, we could say that technically this is two columns. So because a squared plus b squared equals c squared, therefore, right triangle. Triangle. Now, on this one, a squared plus b squared is equal to 25 squared plus 31 squared, which is, if we just use our calculators, we could omit the intermediate step, if your teacher would be okay with this, of course. And we would end up with 1586. C squared is equal to not 1586. How do we know? Well, it's because this is even, and that's odd. Odd number squared gives you odd number. So 1369. So a squared plus b squared are not equal to c squared. Not right triangle. Triangle. All right. Next one is, let's try a squared plus b squared equals 21 squared plus 29 squared. So 21 squared, 441, plus 29 squared, which is 841, is equal to 1282. Now c squared is equal to 42 squared, and that is 1764. Because a squared plus b squared does not equal c squared, therefore not right triangle. You could just draw a little triangle here, or you could write it out. What does this have to do with coordinate grids? We could compare 2 points on a coordinate grid and go, what's the different distance between them? Well, the distance formula is this thing. We use the vertical difference and the horizontal difference. Because the vertical and horizontal axes are perpendicular to each other, There, I think I mimed it right. Anyway, they are perpendicular to each other, therefore there's a right angle. That means you can use Pythagorean theorem to calculate the distance between the 2 points. Like say, the distance between these 2 points. Well, distance is equal to square root of x2 minus x1 squared. The order here, it could be x1 minus x2. They don't actually matter because you're squaring these. Plus y2 minus y1. However, it's best to maintain consistency in case you have to calculate slope at some point. So, in other words, we're looking at this horizontal distance squared plus this vertical distance squared. And if you square root the sum, which is the square of this thing, this hypotenuse, you end up with the length of the hypotenuse. And that's going to be, let's put n down as x2. So, -2 minus 8 squared plus y2, which is 3, minus y1, which is 1, squared. And this is equal to -10 squared plus 2 squared. So that is 100 plus 4. Which is root of 104, or 2 times square root 26. Yeah, round to the nearest tenth if necessary. That's 104 square root, approximately 10.2. Now, instead of d for distance, this could also be magnitude of nm, or magnitude of line segment, or vector nm. So it's the size of the line, because magnitude just means size. Well, let's do some exercises finding the distances between pairs of points. Round to the nearest tenth if necessary. Okay. The distance between AB is, well, magnitude AB, this is how I'm used to writing it, is equal to square root of xb minus xa squared plus yb minus ya squared, which is equal to the square root of xb is 2 minus xa is 3 and squared plus yb is 5 minus ya is 1 squared. So -1 squared is going to be 1, and then 5 minus 1 is going to be 4. 4 squared is 16. And I was like, root of 17. So, this is round to the nearest tenth. That means 4.1 approximately. Alright, what's CD? The magnitude of CD is same old formula. Square root of xd minus xc squared plus yd minus yc squared. So that's going to be xd is 3 minus -2 squared plus yd is 7 minus -4 squared. Okay, 3 minus negative 2. That's 3 plus 2, or 5 squared. And then 7 plus 4 is 11 squared. So 11 squared is 121 plus 5 squared is root of 146. And that's, once again, round to the nearest tenth, which leaves us with approximately 12.1. For EF, once again, we go with that formula. So magnitude of EF is equal to root of XF minus XE squared plus YF minus YE squared, which is equal to XF is 4 minus XE is 5 squared plus YF is 2 minus YE is negative 3. This is squared. So that's going to be 1 plus 25, because this is 2 plus 3 equals 5. Square root of this, so square root of 26. And that leaves us with 26 square rooted, approximately 5.1. Okay, well, we have learned how to find the distance between 2 points on a Cartesian grid. Now, for similar polygons, really, as far as I'm concerned, similar polygons, especially similar triangles, should be at least a chapter on its own. But, well, for now, we'll just cover some of the basics. So if polygons are similar, that means that all their angles match up or correspond to each other. Maybe it got rotated or flipped or whatever. But the angles correspond to each other, and the ratios of all the corresponding sides, which are between pairs of angles, are the same. So they have the same shape, but not necessarily the same size. Now let's say we have these two polygons. They look like trapezoids, but we're not sure. It's not stated, so we don't assume. So we have these which are similar. What is the value of x? Well, because A, B, C, D is similar to E, F, G, H, and therefore, actually, we can state that AD equals 12 a little later. Therefore, AD over EH is equal to CD over GH. And now we can substitute in. AD is 12 over EH is 36. CD is 7 over GH, which is X. So, this is 1/3. If you cross multiply the X over, you end up with X equals 21. Yeah. Do we have to say that it's 21 meters? No. It says X meters. So we don't put a unit on this. Right. We can use the properties of similar triangles, or similar polygons really, but usually we use triangles because they, unlike other shapes where, say, you can turn a square into a rectangle and none of the angles change. With a triangle, to change any of the side lengths, you have to change at least one angle. So you can use the properties of similar triangles to find measurements that are difficult to measure directly. This is called indirect measurement. Now let's say the Chrysler Building in New York casts a 793.5-foot shadow. The same time, a 5.8-foot tourist casts a 4.4-foot shadow. You can tell this question was made in the US of A. How tall is the Chrysler Building to the nearest tenth of a foot? It means. So, let's draw ourselves a diagram, shall we? So the building casts a shadow that's a certain length. Now, a tourist casts a shadow of a certain length as well. We assume that both of these are perpendicular to the ground. We also assume this tourist apparently is like missing half his or her head or something, because apparently it goes straight from the tallest point on their head. The sun just shines straight through. Yeah, something's a little bit off here, but shh, stick person tourist, okay? So they're a stick. Anyway, this is 5.8. This line is parallel. This line is also, these lines are also parallel. And of course, the sun's rays are parallel. Okay? That is why these triangles are similar. These triangles, the angle the people make with the sun's rays are the same. Now, and building, both are perpendicular to ground. And sun's rays parallel. You can say that the ground is a continuous line if you like. The point is that because the angles here that they make with the sun's rays are the same, and these are right angles here, you have angle-angle similarity of triangles. Because of this, therefore, the triangles are similar. Triangles similar. We can label all these points, A, B, C, D, E, F, and so on, and compare, actually state which sides corresponding to which. In this particular case, the diagram is already a bit cluttered, which means we're going to omit some of the same notation we used earlier. That's the notation you're supposed to use, but I, for one, really don't think it's a good idea to write A, B, C around this triangle here. By the way, this is why you don't actually draw your diagrams anywhere close to scale. Like this, where 4.4 is like a fifth as long as 800-ish, almost 800, is already too close to scale for all the other markings to fit. Okay? Yeah. How tall is the Chrysler Building to the nearest tenth? Therefore, x over 5.8 is equal to 793.5 over 4.4. X is 793.5 times 5.8 divided by 4.4, and you end up with approximately 1046.0 feet. Yeah. It's 0.0 because it was 45.977 and so on. So when we round, the 9 got rounded, well, the 7 got rounded into the 9, and then that went up. So let's do some exercises. These polygons are similar. Write a proportion and find the value of x. So our statement would begin with, because ABC is similar to, technically because they're triangles, you should distinguish that fact. DEF. Therefore, AB over DE is equal to BC over EF, which is going to be AB over DE is 5 over 10, 5 meters over 10 meters, is going to be BC, which is 7, over EF, which is X meters. Yeah, this is 1 over 2. So therefore, when we cross multiply, we end up with X equals 14 meters. Now, what about this second one? Well, because the shape MNOPQ is similar to RSTUV make sure that you list all the corresponding points in the same order in both shapes. This is really important, especially if, say, the shapes were flipped or something. Therefore, NO over ST is equal to OP over TU, and that's 17 over 51 is equal to 22 over X. This cancels to 1 over 3. Cross multiply and you get X equals 66. And it's not 66 meters because M, the meters unit, is already marked here. Let's say you have a surveyor. They need to find the distance AB across a pond. They construct triangle CDE, which is similar to triangle CAB, and measures the distances as shown on this figure. Find AB. Well, guys, they should really specify that these two lines are parallel. Otherwise, these sides would not correspond to each other, which would be a problem. Therefore, you have to notice the fact that they specified the points in the right order to know that, yeah, they aren't trolling us with oh, these aren't parallel sides. It's just this is technically similar to that, except in a different point order. Yeah, no. They are not trolling you yet with that level of stuff at this grade level, unless it's right triangles, in which case they might actually go and do it and see if you spotted the difference. Make sure you keep careful track of which order the points come in. Oh, yeah, I should probably underline the C's as well. So, because triangle CDE is similar to triangle CAB. Therefore, CD over CA is equal to DE over AB. CD is 25 yards. Yeah, you can tell that this question was also made in the US of A. So over 60 yards is equal to DE, which is 12 yards, over X yards. This you can cancel out to get a 5, and the bottom can be a 12. So you end up with 5x equals 144. X is equal to 144. I don't need this for divide by 5. What am I doing? When you divide by 5, you divide by 10 and then you times 2. So that leaves us with 14.4 times 2, or 28.8. And, yards is specified on the image, so we just find x, okay? And then AB is equal to 28.8 yards. Yeah, that's where the unit comes in. Okay, well, that's it for now. We'll see each other again next chapter.